Okay, everybody, so today we will be reviewing some key concepts of exponents, radicals, and rationalizing that you've learned in your previous courses. While most of this material is review, we will be focusing on not using our calculator and increasing the level of difficulty when we rationalize expressions. I just want to quickly review our exponent rules. We have operations and properties, which you have learned in previous courses. So our main operations we should know is when you multiply like bases, you add the powers. When you divide like bases, you subtract the powers. When you raise a power to a power, we're going to multiply the powers. And when I have something in a set of parentheses that's being raised to a power, I'm going to distribute. Okay. And whether it be multiplying or dividing, we can distribute that power into the set of parentheses. Our main properties, anything to the zero power is 1. Okay, negative powers. Okay, these are important. So when you have something being raised to a negative power, you're going to flip and write with positive. So if I have x to the negative n, it becomes 1 over x to the n. And 1 over x to the negative n becomes x to the n. So this guy here we're going to use a lot. This guy here we're going to use a lot. This is when we have a fraction power. Okay. We can always rewrite a fraction power as a radical sign, or vice versa. Okay. So I have x to the p over r equals. Okay. The r is going to go in the root, and it's going to be x raised to the p power. A lot of times we're going to kind of think of it in this term, because if we're evaluating, it's easier to take the root of the number first and then raise it to the power. Okay. But we're going to practice. So the first thing we're going to do here is we're going to evaluate, and I want you guys to be able to evaluate with no calculator. I want you doing this math in your head. So this means I'm going to plug in, wherever I see an x, I'm going to plug in 3. So I want to evaluate 2 over 3 to the negative 2 power. And 3 to the negative 2 power is really 2 times 3 squared, which is 2 times 9, which would be 18. Okay, so you should be able to do this math in your head. These examples are quite easy, okay, but you should be able to do it with more challenging numbers as well. In example 2, I have y equals the cubed root of x squared. So this is a perfect example of, I have the cubed root of 64 squared. Now it does not make sense to square 64 first. So if I'm evaluating this in my head, I'm going to take the cubed root of 64 and square it. The cubed root of 64 is 4. 4 squared is 16. 2x to the 2/3 power when x is negative 8. So I'm going to replace x with negative 8 and evaluate this. Now remember, this is no calculator, so you can't just use your caret key. We're going to do 2 times the cubed root of negative 8, and I'm going to take that value and square it. 2. The cubed root of negative 8 is negative 2. We're going to square that number, so I have 2 times 4, which is 8. Now, I just want to remind you here, you can take a cube root of a negative number. Okay. We cannot take a square root of a negative number. Okay, that would be imaginary. So we're going to be careful. Okay, we have to be aware of that when we're doing things. So by square root, I mean any even root. Okay, so just be aware of that. Our next batch of examples, we want to change to radical form. So this means I want to take my fraction power and I want to rewrite it as a radical sign. Okay. So 2x to the 2/3 power means I'm going to rewrite this now. The power only affects what it's touching. So this is going to be 2 times, I have power over root, so the 3 goes inside there, x squared. And there's my answer. This may seem silly to you. All we're doing is rewriting the expression. And the reason we're doing this is later on in the course, there's going to be times when we have to change the form to be able to use a rule or something. So in this part of the course, we're just learning how to change the form. So I have 3 times x to the negative 1/2 power. So this is 3 times, now remember, our exponent only affects what it's touching. So this would be 1 over x to the 1/2. So this is really 3 over the 1/2 power is just the square root of x. Okay. And we are allowed, I know you were told in the past, but sometimes we're allowed to leave the radical in the denominator. That's a hard one for kids in this course because you're always told not to leave it. It's okay. Now I have x minus 1 raised to the 1/3 power. This is a binomial. Okay, so I have my fraction power over root, my cubed root of x minus 1, and this is just to the first power, so I don't have to write anything. However, if this was a 2, right, if it was 2/3, I'd put a little 2 there. Okay. But that is not the case. I'm trying to erase this. That is not the case, so we're going to leave this. Like that. Sorry about that. In the next batch of examples, we want to change to exponential form. So this is another skill that we have to know, how to take a radical and write it as a fraction power. So we can think of these as radical to fraction powers. And now with these types of examples, we're going to have, we're going to want our answer as a single numerator, so we're allowed to leave exponents can be negative. Okay, this is also a hard thing for students to understand. So I have negative 5 times the square root of x, negative 5, x, and this is really when there's nothing inside the square root sign, we know it's a 2. So it's negative 5x to the 1/2 power. The 5th root of x to the 4th. So this is going to be x, remember, power over root, 4 over 5. Okay. All this means is these are equivalent expressions. They mean the same thing in a different form. And now I have x over the 4th root of 2 minus x. So this is really x times 1 over 2 minus x to the 1/4 power. And now we're going to flip this factor, okay, because we want to write it as a single numerator. So I'm going to take this factor, 2 minus x, and I'm going to bring it up and negate it. Okay, that's what we mean by a single numerator. So even though this power is positive, I can write my answer with a negative power. This next batch of examples you may seem more familiar with. This is more like the stuff you did in your Algebra 2 class. So if I want to multiply 2x squared times x cubed, remember, when I multiply like bases, I add the powers. 2x to the 5th power. 3x squared times the cubed root of x. Well, 3x squared is going to become 9x squared times x to the 1/3. Now when I multiply my like bases, I have to add the powers. And this is the part I want you doing without your calculator. I need to add 2 plus 1/3. Okay, so I need to get a common denominator. So this is 6 over 3 plus 1 over 3, and that's going to be 7 over 3. Okay. You must be able to add simple fractions in your head. Or, doing something like that on the side. In example 3, I have 3x squared over the square root of x cubed. So this is my power. My root is 2 if there's nothing there, so this is really x to the 2/3 power. So now when I divide like bases, I subtract the powers. So this becomes x to the, and again, I could separate it out, 2 minus 2/3. Oops. Oh, man. 2 minus 2/3. So I will have 6/3 minus 2/3 is 4/3. And that's your answer. In example 4, I rewrite this as 5x to the 4th. Power to a power. I'm going to multiply. I simplify that first. And now I'm dividing like bases, so I'm going to subtract the powers. So this is 5x. 4 minus 6 is -2. So I have 5x to the -2, and if I was asked to write this with positive powers, I would take that last and final step. Now, sometimes it's going to be okay to leave it with a negative power, and sometimes we're going to want positive powers. And again, that's something that we will tell you in a problem. And for the last problem, number 5, I can rewrite this as negative x to the 1/2 power divided by 5x to the -1 power. There's 2 ways you can do this. I usually just leave the fractions where they are. So I have a number part. This is -1 over 5, because technically there's a 1 out there. So that would be my multiplier or number part. Now I'm going to focus on the variable part. When I divide like bases, I subtract their powers. So this is going to become x 1/2 minus -1 is really 1/2 plus 1, which is 3/2. Okay. The last part of this lesson is going to be on rationalizing. Okay, when we rationalize something, that really means we're trying to get rid of the radical. Now, in your previous courses, you were taught how to rationalize the denominator, and you were told you were not allowed to leave a radical in the denominator. In this course, we're going to change things a little bit. Okay, we're going to rationalize either the denominator or the numerator, depending on the problem. So we just want to refresh our memory. If we want to rationalize something, we multiply it by square root of a over square root of a. Okay. If the numerator or denominator is a binomial, then we multiply by the conjugate, and it's just easier to explain the conjugate when we get to a problem. So in the first 2 examples, we're going to rationalize the denominator. So for instance, when I say rationalize the denominator, it means I want to get the radical sign out of the denominator. In order to do that, I see I have a radical 2 there. So I multiply by radical 2 over radical 2. And I get 3 rad 2. Rad 2 times rad 2 is square root of 4, or just plain old 2. That's what we mean by rationalize the denominator. Okay, we're making the denominator not have a radical sign. In example 2, I will have 1 over 1 minus the square root of x. Now I have a binomial. So what I want to do is I want to multiply the top and the bottom by the conjugate. So the conjugate in this case is going to be 1 plus radical x over 1 plus radical x. Okay. So the conjugate is just you leave the two terms the same and you change the sign in the middle. Now I'm going to try to get you guys in the habit of only distribute what you're rationalizing. Meaning, I'm going to leave this numerator alone. This is 1 times 1 plus radical x. I'm going to leave it alone. Okay. If there was a 2 out in front, you would maybe try to distribute it in. Do not do that. Okay. Only distribute the denominator here because this is what we're rationalizing. And hopefully you remember from last year, when you FOIL conjugates, first times first, my outside is plus radical x, my inside is minus radical x, and then I have a minus radical x times radical x is plain old x. So in the denominator, I'm going to be left with 1 minus x. Okay. And this is your answer. Notice we got rid of the radical sign in the denominator, and we're left with 1 in the numerator, but that's okay. And just as a reminder, when you FOIL conjugates, it's first squared minus last squared, if you want to save yourself a little time. Okay. Rationalizing the numerator. This is a little more confusing, okay, because your answer is going to move the radical sign to the denominator, and it's going to be confusing at first, but you will get used to it. So to rationalize the numerator, I look and I see that even though this is a binomial, it's still one term. So I just multiply by that whole radical. Now, when I multiply these together, since I'm squaring, essentially squaring, right? I'm just going to be left with x plus 1 in the numerator and a radical x plus 1 in the denominator. Don't be scared of this answer. Remember, it's okay to have a radical in the denominator. I told you to put it there. Okay. We wanted to get rid of it in the numerator. Okay. And there will be reasons for it later on in this course. And lastly now, for example 2, rationalize the numerator. Okay, so I'm going to actually rewrite this problem because I don't want to change the example. Okay, I want it to be nice and neat. So I want to rationalize the numerator, which means I'm going to take and multiply by the conjugate, top and bottom. Leave it alone, change the sign, leave it alone. Top and bottom by the conjugate. So when now remember, I'm going to FOIL the top out. First times first. Outside, inside is just going to cancel each other out. Minus, now I'm going to take last times last. So I'm subtracting x plus 3. Okay, that's a quantity you're subtracting, so make sure you put parentheses around it. So in the numerator, I'm left with x minus 3, and in the denominator, do not distribute, just leave it alone. That's what I meant before, only distribute what you're rationalizing. Going across the top, x minus x is just 0, so I have a negative 3 in the numerator and 3 times radical x minus radical x plus 3 in the denominator. Our 3's are going to cancel, and I will be left with negative 1 radical x minus radical x plus 3, and that would be your final answer. Okay. Just remember, it's okay to have the radical in the denominator. We got rid of it in the numerator. That's what the goal of the problem was. I hope you found this video useful, and we will